Okay, so this is probably my last calculus video. It's about rates of change, and it's basically the concept that in a lot of differentiation and anti-differentiation, we have been looking at gradients of curves. But we don't always want to know about a gradient of a curve. Maybe we want to know about how quickly a volume is changing or an area is changing. And that's the same idea. It's the same concept. You're looking at a graph, but you wouldn't immediately think you're looking for a graph. So here I've got the volume of water in a reservoir at a time of day t hours after beginning is given by this. So instead of having y, I've got v, and instead of having x, I've got t. But really, nothing else has changed, and the rate of change will be dv by dt. So if I differentiate this as per usual, now remember differentiation is multiply by the power, subtract 1 from the power, so I get 12t squared over 5 plus 12, well, there's no value of t in there, so like a constant when we had an ordinary one with something involving x, that ends up being differentiated away. So I've got the rate of change, which is dv by dt, as 12t squared over 5. Now they want me to find the rate of which 5 hours after it begins, so t equals 5. So this is me like doing my normal differentiation and substituting a value in to find the gradient. My rate of change, which is dv by dt, is 12 lots of 5 squared divided by 5. Now I could multiply that out. Personally I'm not going to, because I realised that 5 squared and 5, well, the square is going to cancel out, and I'm going to be left with 12 times 5, which is 60. Now that is 60 meters cubed per hour, because it's the volume divided by the time. Much the same as, you know, when you work out from distance to being a speed, you do the distance kilometers divided by the time, which is hours. So you've just got to be careful about the units, but to be honest, I'll be amazed if they get picky about units in this. So really that's it. So basically a rate of change is actually just an ordinary standard differentiation, and at that point you'll be sweet.